Hi friends, welcome to the Unit 3 Day 4 notes. Now we're going to be sketching graphs of polynomial functions using the examples that we talked about in the last video. That guidelines that we were discussing talks about essentially different steps to follow as we go through. Feel free to follow along as we go through as well. So for here, we're sketching this particular graph of this polynomial. I went ahead and wrote some of the steps down here so we could follow it. The end behavior of the graph we get from looking at the leading coefficient and the degree. Notice that it's in standard form already, so I don't need to change that. It's an even degree, and then the leading coefficient is negative, so that means it's going to go down. As x approaches negative infinity, your f of x approaches negative infinity. Negative infinity. Not with a slash through the negative sign. And as x approaches positive infinity, your f of x approaches positive infinity as well. So I know that the graph is going to continue going down. The y-intercept I get from looking at, in standard form, just the constant term. So the y-intercept is going to be 0, negative 12. So for here with the zeros, we can talk about different ways to establish that. Because it's in standard form, I'm going to have a little bit of a different time to find the zeros. Remember, we can start getting the scale here, but not knowing where the zeros fall, I may need to go by a different value. Notice that this grid is a 10 by 10. So 10 by 10 is the reference. It's fully pointing across negative 10 to 10. But it's 10 grid squares, 10 grid squares. So the zeros. Looking at this without having any indication of kind of the path to go, I'm going to follow just to see if there's something that I can factor to help make my life easier. Looking at this, I can't do factor by grouping because if I factor out something in this part here, I won't get the same thing when I factor out here. So just looking at it, this is an x to the fourth, and then this is an x squared. So these two decrease in degree by 2, whereas these two just decrease in degree by 1. So factor by grouping isn't going to work. The next thing I would do is probably use the rational zeros theorem to figure out what sort of zeros I would have. Remember, that's p over q, where this is p, and then q is here. So just kind of going through, that's going to be plus or minus 1, 2, 3, 4, 6, and 12. So those are possible, So those are possible rational zeros that I could follow with this. If you're just checking zeros, again, I have my graphing calculator here, but I'm not actually going to graph it. So this entire thing, I'm not relying on my graphing calculator at all. So I'm using just my knowledge of everything so far without the tools, the technology tools. So at this point, I would try either 1 or negative 1 using synthetic division to see if it factors and I get a remainder of 0. I'm going to do positive 1 first. Notice I'm doing it off to the side here in this space, so that way I can just keep this space clean with kind of the finished product of what I find. So my leading coefficient's negative 1 for x to the fourth, 0x cubed, this is something a lot of students miss, 9x squared, negative 4x, and then negative 12. Bring down the negative 1 times 1 is negative 1, negative 1, negative 1, 8, 8, negative 4, and I get a remainder. So this one, not going to work. If I try negative 1, I might get a different result. So 1, 0, 9, negative 4, negative 12. Bring down the 1, negative 1, 0, and I have 1, 10, negative 10, negative 14, positive 14, negative 2. Or sorry, positive 2. Still a remainder though. So far, this is not showing any promise. Next thing I would check is 2. Negative 1, 0, 9, negative 4, negative 12. Bring down the negative 1. Negative 1 times 2 is negative 2. Negative 2, negative 4, 5 is 10, 6, and 12, and then that gives me 0. Hooray! So the fact that I used 2 to find it, remember that means that one of the factors here is going to be x minus 2. so that I'm just going to write in the zeros. One of my zeros is going to be 2, and then I'm going to note one of my factors is x minus 2. That is just to kind of keep everything in line. So this was an x to the fourth. This brings it down to an x cubed. So this is negative x cubed minus 2x squared plus 5x plus 6. Again, looking at this, factor by grouping doesn't look like it'll work, again, because of that 5. So again, I'm checking as I'm going through just to see what this gives me. I got to this point with 2. I've already checked 1 and negative 1. A lot of times students will go back and recheck something they've already checked. Instead, I'm going to move on and try negative 2 at this point. So negative 2, I'm using, again, this lower degree polynomial as I go through. So bring down the negative 1. Negative 1 times 2. Negative 2 is positive 2. That gives me 0. 0 there. 5. 5 times 2 is negative 10. So that did not work because I got a remainder of negative 4. Let's jump to positive 3. So again, going back to here, positive 3, checking negative 1, negative 2, 5, and 6. Bring down negative 1, negative 3, negative 5, negative 15, negative 10. Negative 10 times 3 is negative 30. Negative 24. Not working either. All right, negative 3, maybe. You can see why I did it on this side. Negative 1, negative 2, 5, 6. Bring down negative 1. Negative 1 times 3, negative 3, excuse me, is positive 3. Positive 1, negative 3 is 2. 2 times negative 3 is negative 6. So this did work. So that means negative 3, with negative 3 being a 0, listing out here, that means x plus 3 is going to work. Now I'm left with this quadratic. Now, as soon as I get to a quadratic, it's very nice. It's very nice to go through and solve. Minus x plus 2 equals 0. Because at this point, you could just use the quadratic formula. Because it's a negative, at this point, I would factor out a negative 1, which will change the signs, but it won't change the value. Plus x minus 2 equals 0. It won't change the value of what I'm trying to find in terms of the zeros. So just keep that in mind. So I'm going to check to see if I can factor this to get this to be nice. So if I have this, factor out the negative 1. If I factor this here with the negative 2, and this with the 1, so let's see, that would be 1 and 1, 1 and 2. I know the signs would have to be positive and negative. So here, that's plus 2 and that's minus 1. Let's check that, see if that works. So here I have x plus 2 times x minus 1. That's negative 2, positive 2, minus x. So here I have a 0 equals 0. Forgot to include that at the end. Here equals 0. So here I have x plus 2 equals 0 and x minus 1 equaling 0. So that gives me x equals negative 2 and x equals 1. Now this is a red flag. This probably means that I made a mistake in my multiplication from above because we found out that x couldn't have been 1 from earlier. So if I go back and check with x equaling 1, I'm just going to check to see these two because it looks like I may have made a mistake in multiplying. Some of you are probably already seeing that. Negative, that's negative 1, 8. 8 times 1 is 8. Negative 4, negative 4, negative 16. 1, bring down the 1, negative 1. 0 plus negative 1, that's positive 1. 9 plus 1 is 10. Negative 10, negative 14. Negative 14. I have no idea. I'll probably see it right after the video. That's usually how these things work. So here I have zeros at x equals negative 2 and x equals 1. And going through, now we have 1, 2, 3, 4 zeros. And then with those 4 zeros, we have now our points that we can plot. So it looks like the y-intercept, the only issue is that it goes off the graph if I go 1 by 1, or if I go by 1s. So for here, I'm going to go by 2s. It'll squeeze this a little bit. I should be fine for the most part. So 2, 0, negative 3, 0, negative 2, 0, and 1, 0. That's going to be here and here. That's a little bit squished, so I'm going to instead go by 1s. Yeah, I'm going to have to go by 1s on my x-axis and then 2s on my y-axis. So I'm going to go 4, 8, 10, 12, 16, and then 20. All right, so now I've got 1, 0, and then 2, 0, negative 3, 0, negative 2, 0. So these all are going to intersect. So I know that it's going to go like this, like this, like this, and like this, going down. My y-intercept is at negative 12, so that's going to be 2, 4, 6, 8, 10, 12. That's going to be down here. So I know that these are going to intersect here, here. So what I don't know is kind of how far there's a maximum here and a maximum here between these two. I don't know how high it goes. This is just a rough estimate to give me my best shape of the graph. So this is the best that I have with the information on the graph given so far. This does match the end behavior. I got my y-intercept of 0, negative 12. I have all of my x-intercepts. So 2, 0, 1, 0, negative 3, 0, and negative 2, 0. So I have all of those labeled as well. Join me in the next video as I graph the last one.